So now we know the different types of nuclear radiations that come from unstable nucleus in elements. Now, radiation is a bigger umbrella of different types of energies that can be released. And it is important to know that there's biological effects of radiation. Radioactive emissions in general, they contain a lot of energy and they will interact with many atoms. So, there are some health risks associated with radiation, but it is important to note that it depends if you have non ionizing radiation or if these are going to be ionizing radiations. In the image that we have right here on the slide, you can see that there's the beginning blue arrow pointing towards the left, which give you examples of non-ionizing radiation. And by looking at the images down here, you may see many objects that are around us in everyday life. You may also notice that towards the right, so pointing towards the right, we also have examples of ionizing radiation. And you may also see images of things that we may have been exposed to just in everyday life. So first, when we talk about ionizing versus non-ionizing radiation, we're going to define them, and then we're going to talk about their exposure. So the first thing that we're going to discuss is ionizing radiation. By definition, ionizing radiation is a high frequency radiation that has enough energy to remove an electron from an atom or a molecule. That's where the ion comes from. Now that you remove an electron, since electrons are negatively charged, now you will be creating charged species, which we call them ions. So that's why the term is called ionized. Now, ionizing radiation has enough energy to damage DNA in cells, which that can lead to mutations, and mutations can lead to cancers. So that's one of the concerns when it comes to radiation, and depending how much radiation you are exposed to. So some examples of ionizing radiation include all of the nuclear radiations that we learned previously. And in addition, you can see here that we have ultraviolet, but ultraviolet, high energy ultraviolet rays, and also X-rays. Now I highlighted those in gray because those type of radiations are part of what you can see in the corner. They are part of electromagnetic radiation. And electromagnetic radiation is not going to release a particle. That is a different type of radiation. They are actually coming from the idea that there is a photon, which is light that forms a wave, and that wave is overall what creates that electromagnetic radiation. There's not a big discussion about electromagnetic radiation in the textbook, but I wanted to specify that ultraviolet and X-ray are not nuclear radiation sources, or they are not coming from unstable nucleus of elements. Now, are we exposed to ionizing radiation? Well, people may be exposed to ionizing radiation from three main sources. The main source is the natural background radiation. This type of radiation comes from cosmic rays that are part of the solar system. The other way in which you can have natural background radiation is because there are certain radioactive elements that could be in soil, and if they are in soil and water gets exposed to it or food products get exposed to it, then that can affect human populations. Medical radiation is another source of exposure for ionizing radiation. Understand that in diagnostics as well as treatment, sometimes radiation is utilized. So, in terms of medical radiation, we can see that some imaging tests, including X-rays, are going to be exposing people to low levels of radiation. And you can see here on the right side of the slide that we have an image for an X-ray. Understand, MRI which MRIs is magnetic resonance imaging, and ultrasounds are not radiation. That's just different techniques. Now, there's a third type of ionizing radiation that you may be exposed to, and that is non medical or human made radiation. When it comes to the workplace, there are certain jobs that can expose people to radiation. So, for example, flight attendants, once the plane is in a certain altitude, you could receive radiation from the sun. That's why they have regulated flight schedules and they cannot be working all the time with many hours just because of the exposure of radiation through the workplace. Now, man-made radiation has also happened. As you can see here, above ground nuclear weapon testing that took place in 1962 may have exposed human populations to ionizing radiation specifically. If you want to read more about it, this has to do with the Starfish Prime experiment that was conducted in July 9th of 1962. Understand that this test was conducted by the United States in space, and this led to the discovery and understanding of nuclear magnetic poles and their effects. And just to give you guys an example of human exposure during this experiment, this experiment led to the generation of this electromagnetic pulse that actually damaged the electrical system in Hawaii. And that is, an example of human-made radiation. Now, let's now discuss what is non-ionizing radiation. Non-ionizing radiation is low-frequency radiation that does not have enough energy to remove electrons or directly damage DNA. So, some examples of non-ionizing radiation include low-energy UV rays, visible light, infrared, microwaves, radio waves, among others. And you can see by looking at the images that are under that blue arrow, some of those non-ionizing radiations that you may have exposed to. The only ones out of all of them that may be thought to have an increased risk for cancer is going to be UV rays. Other than that, all the other ones, to date, we don't have evidence how they could affect biological systems. And if we look at them, sometimes understand that we are exposed to them in everyday life. The last thing about radiation that we need to know is the understanding of how can we protect ourselves to radiation. Remember that radiation, especially the ones that are higher energy, they can penetrate farther into the tissue. And in this concept, we already learned that alpha particles, beta particles, positrons, and gamma rays, all of those are actually ionizing radiation. So if in the laboratory you need to work with them, you need to have protective gear and work with them properly in order for them to not cause health risks. So, as you can see, people that work with radioactive material may wear a heavy lab coat, lab glasses, gloves. They may even have to stand behind plastic or a lead shield. But again, it all depends on the type of radiation that they're working with. Moreover, maybe if you have been to the hospital, you may have seen that some of the employees actually have this little apparatus that you see here. In terms of the size, I just say little just because of the image. But understand that sometimes, depending on your line of work, people who routinely work with radioactive materials usually wear a film badge that actually monitors their total exposure to radiation. When it comes to what do you need to know in terms of the radiation protection, table 2.5, you should have for exam 1. As you can see, it is summarized in table 2.5, the common properties of some examples of ionizing radiation. And here I just included the nuclear radiations that we learned previously in this chapter. Now, all the descriptions here, what they're doing is for each one of the nuclear radiations that we learned, we see how they travel through air, how they can penetrate tissue, and lastly, what will be the protective shielding necessary in order for a person to protect themselves from that nuclear radiation. So be familiar with all of the descriptions that are contained in table 2.5.